Okay, welcome to this quick discussion on productivity. And remember that with productivity, we're dealing with a ratio, an index, and it's also a ratio. And it is a relative measure that takes on meaning when we compare it to other measures. So we need to compute productivity based on common information, or we should not compare it. In this case, we're going to compute inside one organization and use sales as the output, and then divide by a few different inputs and see the difference from year to year. Okay, so productivity can be a single factor productivity, which is when we take one input, or it can be multi-factor, where we take a group of inputs. All right, and we're going to look at that both ways. We're going to look at how to solve this in Excel, and let's go ahead and do some calculations then. So here is our output for this exercise. I'll highlight that in green so you can keep it straight. And we're going to look at two different inputs. Phone rep costs. So that's what the company is paying its phone reps. And we'll say for this example that it's the fully burdened cost of those people who do the selling, those phone representatives. And this is our website cost. And we will say for this example that these are the full costs of our website. And regardless of how we've constructed it, it could be completely outsourced. It could be fully running on our own servers with our own developers. But that's the cost, the full cost of the website. Okay, so these are both inputs into the sales process. Sales reps and a website, a customer-facing website. Let's see how we would solve then the single factor productivity for our sales rep costs, our sales over our telephone representative cost. We would simply say in Excel equals, and we would select that output, this C column cell, / is divided by, and then we would select the phone rep costs and hit return or enter on our keyboard. Now, because the relationship is the same between these cells, and all of these cells compared to what I did here, I can use this copy cell command, left click, and pull down for as many cells as are identical. Okay, so there you have it. Those are the ratios for all these years. And if you look inside one, you'll see equals C15 divided by D15, which is right here, C15 and D15. So it worked properly. Now, we could not just drag this across because it would correctly move to E's relationship to here, but it would also move, instead of dividing by sales, we're dividing by phone costs, right? Because the whole relationship would move over one. Now we can preserve C if we go in here, and before C, we put a $sign. The $sign says when we copy that cell, it won't move that particular relationship, that's C. So now we can copy this across. And if we go in here, we'll see it kept $C10 and it moved D to E. See the E there, right? And so then we can do the same thing and copy that down because the rest of the relationships may remain the same. Okay? And those are your ratios for the website cost as the input to that sales output. This is a multi-factor productivity in column H. And so for column H, we need to sum these two. We need to add these two together. So let's just create a new one for that. We'll say equals our output / which is divided by, and then we need to basically add these inside there. So we'll click on D plus E, and we'll put the other side of the parentheses in, and we get our multi-factor productivity, which represents for 2012 the total sales divided by the combined rep costs and website costs. Okay, those relationships all stay the same, so we can copy it down. Now we can see, if it has value to us, the relationship between the ratio relationship. We have to be careful about causation. That's a whole nother conversation. But we can see a ratio relationship between the cost of our sales reps and our total amount of sales over a period of years. and we can see the single factor website relationship to all of our sales over the years. And maybe more importantly, let's say if those represented the bulk of our marketing costs in a simple business, we might be able to look at the ratio of our marketing cost over years, right, to our total sales productivity. Because the index ratio is rising, it means it is improving. Our outputs are over our inputs. So as the number goes up, our productivity improves year to year. We could also take an average of those. And in Excel, there's long ways of doing it. The short is to say equals average. And then with the parentheses, we can select these numbers, right, that we want to average, close it off with parentheses, and hit return. Right? And we could copy that into all three of these if we wanted to see all three averages. On average, for 6 years, we're at 34. Well, now we're at 46 here, but that's dangerous. These single factor productivities can be dangerous because we start getting, unintentionally start thinking about causation. When we group them together, in this case, I would make the case that this is a more meaningful and more powerful number because it's our total investment in our selling activities and our marketing activities in their relationship to sales. Of course, that also can be dangerous because we could find out that it was all due to product development and that we're just terrible in the sales rep department and we're terrible, have a terrible website, but our product is so good it sold itself. So we always have to be careful with causation. But we can see a ratio here and we see that it's improving. And in the next exercise, we will measure how to measure this change in productivity year to year. Okay, so if we can see the productivity for the phone reps for the past 6 years. That was part A. We can see the productivity for the website. Whoops, sorry, there's the phone reps. There's the website. And there's the multi-factor productivity. And then we went ahead and averaged those just for a point of reference at the bottom. Let's look here at another example. So here we have SunPath Manufacturing, 2 different years, and a number of inputs, a broader number of inputs, a manufacturing-oriented group of inputs. Here's our sales. I've labeled it as an output for you. Okay, and here I've informed you what the inputs were. It's all of these group. So the easy thing to do with Excel would be to, of course, first total up these inputs. So let's do that. Whoops, I did it the wrong way. Hit the auto sum button. That's what I meant to do. And total those up. I can just copy it over, right? Like so. Or I could come up here to auto sum and do it again. Now it's important to make sure you do not grab the output. And I want to show you one thing too, because some students make this mistake. When I select auto sum, it takes its best guess. Watch what it does here. It grabs all the numbers, bless its heart, right, that it can see in a row above that. If I were to delete one, oops, sorry, okay, go back here, delete that formula. If I were to delete the 63,000 and hit auto sum, it stops here. And I would have to say, no auto sum, I want it all the way up to the 42, right? And let's put that back in. What was that? 60,000? All right, whatever it was. I think it was 60,000. Now let's go back. We'll get the right number in there. 63,000. But also notice that AutoSum is grabbing the year, the output, the whole enchilada here when we do have numbers in a row. So we need to correct it. Just left click and drag the cells we actually want. Hit return. And there we go. Okay, so what is the productivity in 2012 and 2013? What is the percentage change between those two? Well, our 2012 multi-factor total productivity, right? Total productivity is going to be all these numbers. So we would say equals our output, 375,000. Click on there, / by the sum of our inputs. And there is our total productivity for 2012. What is it for 2013? Well, that would be simply equals our output divided by this sum as well, which I can just click this. I don't need to sum it again. And I see the 2 years productivity index. We see it's going up, so we're probably pretty happy. We went from 1.221 to 1.247. But what is the change? All right, so the way we find the change, and I put it up here for you, a little formula. It's basically you take the new, this year, you take the new index minus the old index, and then divide by the old index. So how would we do that in Excel? Equals our new index minus our old index divided by our old index. And I probably need, I need brackets on that equation, right? So let's put them in there and get that number right, because we got to do our subtraction before we do our division. It's a 2.09% increase in productivity. All right, and what is the labor productivity measure? So that's a single factor productivity, right? What is the percentage change on the labor? And what is the labor and what's the percentage change? So we would go back here. Let's hide these columns. Oops, let's hide these columns real quick so we can see everything. Okay, so we would basically simply say equals our output. We've been given an output, right? Divided by the labor. And we would do the same for 2013. Equals our output / which is divided by our labor, hit return. To find the change, we would do the same as the other that I just showed you. We would say equals our, in fact, this time I'll bracket it from the beginning, equals bracket our new productivity minus our old productivity. Put the other end of the bracket in, divided by our old productivity. 2.78% increase from 2012 to 2013 in our labor productivity. Okay, and we can do the same then for capital. I'll hide these off, pull that up so we can see it all at once, hide these columns, and we do the same measure. So this is for capital only. So we would say equals our output divided by our capital expenditure only, and there's our index. And for 2013 equals our output divided by our single factor, our capital. Okay, and we see it went the right way. That's good news. Okay, and then of course we can do this again, which is equals our bracket that, and it's the 2013 minus the 2012 with a bracket on the other end, / 2012 is 2.91% increase. Okay, so a last question was, without calculating but using the 3 measures that we did for A, B, and C, what conclusions can you draw about productivity? So here's your managerial question. Let's unhide these so we can see them and take a look at what we had here. Oh, we got to unhide some more. Oops. Look out. Unhide. Okay. So we had an increase in the overall of 2.09%, and labor productivity was higher than the 2.09 average, and capital productivity was higher than the 2.09 average. So what I was hoping students would notice in that question is that if labor and capital are both higher than the average productivity increase, that we've got something else going on somewhere else that might be problematic, and we better figure out what it is. Because we know that as a whole, the ones that we didn't do, which was materials, energy, and other, somehow those are pulling us down because something is below the average. So as a management team, you might look at this and say, okay, our average productivity is 2.09, labor is above that, capital is above that. I wonder if we've got a problem somewhere that we need to at least be aware of. Is our materials bill rising rapidly? is something going on in our overall equation that we need to be concerned about in the ratio. Because these two are significantly above the average, something else has to be pulling it down inside that's baked in the cake here. That is our Excel sheet on productivity. And hopefully you might have learned something about Excel. And not that I'm an Excel master, but I'm a pretty good hack, and it's a very important skill to have even at the basic level in just about any business organization worldwide. So there you go. That concludes our session. Have a great day.